Lesson 88, Review of Proportional and Non-Proportional Relationships. First off, let's look at what proportional relationships look like. They involve two variables that can change value. So an example of y equals kx, which is direct variation. If you were to rewrite that to have equal ratios, you can solve for the constant and you would have y divided by x. If you have a bunch of coordinates from a coordinate plane and you put them in a table, if you were to take your y value and your x value and divide them, they would all equal the same constant. That would be proportional. The graph is going to be linear and aligns with the origin. It can be continuous or just points. So if it starts at the origin, 0, 0, and everything else forms a straight line, then it is a proportional relationship. It could still be a straight line and not cross the origin, but it will not be a proportional relationship because it does not go through the origin. So two things for a direct proportional relationship. Number one, it has to go through the origin. Number two, it's got to be a straight line. So let's take a look at some examples here. Here we want to state whether each graph below depicts a proportional relationship. So we're just going to say either yes or no. The first one, the taxi fare. Notice the first point starts up here. That's not the origin, but it does form a straight line. But no, this is not a proportional relationship because it doesn't go through the origin. The second one starts at the origin and our points do form a straight line. So yes, this is a proportional relationship. And the third one here starts at the origin, but if you notice, if we plot points along the line, it doesn't form a straight line. It's got a curve. So we would say no, this does not have a proportional relationship. The second one, the following tables record the effect of dilating on the perimeter and the area of the square. State whether it shows proportional relationships. So in order to solve these with the tables, we just take our y value divided by our x value, or in other words, our perimeter divided by our side length. So 8 divided by 2 would give us 4. 12 divided by 3 would give us 4. 16 divided by 4 is 4. 20 divided by 5 is 4. So this one, yes, it is direct, or it is a proportional relationship. This next one, do the same thing. Our y divided by our x, or our area divided by side length. 4 divided by 2 is 2. 9 divided by 3 is 3. 16 divided by 4 is 4. And 25 divided by 5 is 5. They all have different constants. So no, this is not a proportional relationship. So let's make sure when you're doing these, you're always taking your y divided by your x. Next one, the equation y equals kx transforms to y divided by x equals k. It means that the ratio of y to x is constant. If y divided by x equals 3, then which pair of numbers does not fit the relationship? So we need to take each one and divide your y and your x to see which one equals 3. There's going to be one that does not equal 3, and that's the one we're looking for. So 12 divided by 3, or 12 divided by 4 is 3. 18 divided by 6 is 3. 3 divided by 9 is actually 1/3. So the one that does not fit the relationship would be C, 9, 3. Next one, which of the following is not an example of proportional relationship? Distance and time when driving at a constant speed, quantity and price when the unit price remains the same, or C, the hours awake and hours asleep when the number of hours in a day remains the same. For this one, the distance and the time when driving at a constant speed. If you're going at a constant speed, you can go a certain distance in a certain time and divide your distance and time, you're still going to get that same speed because this stays the same. So distance divided by your time does give you your speed. The quantity and price when the unit price remains the same. So if you buy 5 of one item and it costs 50 cents, it's still going to, the ratio is still going to be the same if you bought 10 of them at the same unit price of 50 cents. So the only one that is not proportional would be C. Just because the number of hours stays the same doesn't mean that you sleep the same amount of hours each day or you're awake for the same amount. That's going to change each day. Next one, the heights of similar triangles are proportional to their bases. As a triangle is dilated, its base and height increase proportionally. Predict the height of the triangle when the base is 15. So the first thing we need to do is find out what our constant is. So our base is x and our height is our y. So if you take 3 divided by 2, which would just be 1.5. So if I take my constant 1.5 and multiply that by base 15, I would get an answer of 22.5. If you're wondering how would we determine this, or how would we set this up? Well, if we take our base and our height, and it says that as a triangle is dilated, its base and height increase proportionally. Well, in order to find the height, you would just take your base, multiply it by the constant, which is 1.5. Or in our case, to find the constant, we just took our height divided by our base. So 3 divided by 2. I could have done 4.5 divided by 3, or 6 divided by 4, or 7.5 divided by 5. You would still get the same constant of 1.5. Our next example, state whether each equation below indicates proportional relationship. So the first one, circumference equals pi times diameter. There's 2 variables on each side of the equal sign. The constant pi multiplies one variable. So this would be proportional. This would be just like saying y equals kx, with c being our y value, d being our x value, and pi being the constant. Next one, area equals pi times radius squared. Because it's got that square on this variable, it is not a proportional relationship. Yes, it does have a constant in there, but the variable r has an exponent of 2, so it's not going to be multiplied by a number that's proportional because we're squaring every number. And the third one, C, y equals 2x plus 1. This one is not proportional because if we were to graph this, it would not cross the origin because of this plus 1 here at the end. For it to be proportional, it can only be in this format. Y equals 2x, or rate times time equals distance, or circumference equals pi times diameter. You need a constant multiplied by a variable. Next one, which of these problems can be solved with proportional thinking? It takes 2 workers 5 hours to complete the job. How long would it take 4 workers to complete the job? And letter B, the shipping charge is $2 per item plus a $3 flat fee. So it costs $13 to ship 5 items. What is the shipping charge on 10 items? And then our third one, each student read the same number of books. 30 students read a combined total of 150 books. How many books were read by 60 students? So if we take a look at which one would have proportional thinking, letter A, it takes 2 workers, 5 hours to complete the job. How long would it take 4 workers to complete the job? There isn't a constant in that one, so we know it can't be A, because it's not going to be the same amount of work, same amount of time for 2 workers as it is for 4 workers. That's going to change. The next one, the shipping charge is $2 per item plus a $3 flat fee. So it costs $13 to ship 5 items. Because you have this plus $3 flat fee, that's a clue that it's not going to be a direct or a proportional relationship. So the correct answer would have to be C, because everybody reads the same number of books. So we have a total of 150. So if there are 30 students, that means each of the students would have read 5 books. And so since they're all reading the same number, that would be constant. You can always divide the total number of books by the number of students, and that will give us the number of books that everybody has read. And our last questions, which graph below shows a proportional relationship? So again, have to go through the origin, and it's got to be a straight line. The only one that does that here is letter A. And the last one, which equation is an example of a proportional relationship? So it has to be in the format of y equals kx. And the only one that shows that would be A. It cannot be C because it has an addition sign in here. It cannot be B because it's got a square there. So that's our lesson today on solving proportional and non-proportional relationships.